Section 1.2 is functions and graphs. The first thing I want you to do is pause the video and read through your definitions and also look at the solutions for the domain and range in part A and B and see if you can make those connections. After that, unpause it and we'll go from there. Okay, after you've read through this, the domain is just going to be your x values. If it's repeated more than once, we still only write it one time. The range is the y values. And function, this is where we're going to discuss. Function says every x has exactly one y value. So when we want to look at our x values, right here we have 9 and 9. This x value repeats, therefore every x doesn't have exactly one y to go with it, because this x value has a negative 5 and it also has a positive 5, therefore this one is not a function. The next problem, B, we're going to look at our x values and we see that negative 2, 5, 0, and 4, none of the x values repeat, therefore this is a function. Every x has exactly one y. C, the domain, every x is paired to exactly one y. It's a direct correlation, so yes, it is a function. In D, the x value negative 1 is paired with 0, and it's also paired with 3. It has more than one y value to go with it, so this is not a function. Our next problem asks us to evaluate the graph, so if we look at this of f of x equals y, it's asking us when x is negative 5 from right there, what does the y value equal? So when I go over to x is negative 5, which is here, it's saying where's the graph at? The graph is at negative 2, the y value of the graph. Now I'm going to do when x is negative 2, where's the y value? When x is negative 2, I need to know where the y value is. So 1, 2, 3, 4, 5, 6. The y value is 6. When x is 0, where's the graph at? It's negative 2. And when x is 4, so 1, 2, 3, 4, when x is 4, the y value of the graph is 0. So that's pretty simple. We're going to go to the next problem, which says evaluate is indicated. So they give us our function and they say evaluate that. So the first thing, I'm going to start with my function that was given, and then I want to, this time, everywhere x is at, I'm going to put a 3. So everywhere x is at, you put a 3, and the rest of the problem is exactly the same. Evaluate, order of operations, 3 squared is 9, 2 times 3 is 6, then we're going to do 3 times 9 is 27, minus 6 plus 1 is 22. So g of 3 equals 22. Okay, problem B, we start with our g of x function, which is a 3x squared minus 2x plus 1, and this time we substitute negative x in everywhere x is at, and then the rest of the problem is the same. Negative x squared is just x squared. Then I bring down 3, negative 2 times negative x, then plus 1, and this doesn't simplify any further, so that's our solution. Next, we have vertical line test. It says if a vertical line passes through 2 or more points, it is not a function. So I'm just going to draw some vertical lines, and if it only touches the blue graph at one point, it is a function. If it touches it at more than 1 point, 2 points, it is not a function. So this part right here makes it not a function because it touches 2 points. This one is yes, it is a function. No, because it touches 2 points. Yes, it's only touching 1 point at a time. This one is a function because this blue part's included, but this open graph means it's not included. So yes, it's only touching 1 point, and yes, it's only touching 1 point. Those are fairly easy to determine. This next page we're going to be talking about domain. The domain of a function is always all real numbers represented negative infinity to positive infinity, except when these two situations occur. Pause and read these two circumstances. Using our previous definitions, we're going to find the domain of each function. In A, they give us a function. As long as it doesn't have those two exceptions, we said it was always going to be negative infinity to positive infinity, all reals. B says if you have a variable in the denominator, that's one of our exceptions. So we have to take the denominator and set it not equal to 0 and solve it, because this is one of our special cases. So x cannot equal 2. X cannot equal 2. If I draw a graph of that, that means x can be everything but 2, so it's an open circle on the 2, and it's shaded in both directions, everything else on the number line. Interval notation of that is going to be negative infinity to 2, and it's a parenthesis because it's an open circle, and then it goes from 2 to positive infinity. C says if there's a variable under the radical, then that's also our other exception. So we take x minus 8 and we set it greater than or equal to 0 and solve. Divide both sides by negative 1. Remember, when we divide, we're going to have to flip our sign right there. So we get x is less than or equal to 8. The graph of that is going to be a bracket. Less than is shaded to the left. So I need to write interval notation. Interval notation is going to be from negative infinity to 8 with the bracket, or we can use our original value we got here, x is less than or equal to 8. Our final problem for this is determine the domain and the range. We said domain is the x values, and we want to know how far to the left and how far to the right does our graph go. The range, we're going to want to know how far from the bottom to how far to the top. So when we look at our domain, it's how far left. That goes to negative 3 to the left. And we want to know what's our furthest point on the right. That's this point right here, which is going to be at a positive 5. Our range wants to know how far from the bottom. Our bottom point is here, which I calculate is going to be negative 4. And our top point is going to be here, and I count up, and it's going to be 6 units. So it's that. The range of the domain of this next problem is going to be how far to the left. This is our leftmost point, which is negative 2, and it goes to the right this point, but since that's an open circle, I have to use a parenthesis on the 4. And then my range is going to be from how far from the bottom is negative 2, how far to the top, positive 4 with the parenthesis. And the last one, we look our values, let's check our answer there. Domain goes negative 6, and it goes on forever, so it's infinity to the right. And then from the bottommost point is going to be 0, and it goes on forever to the top, so it's also going to be positive infinity. You mostly just have to keep this idea right here in mind when asking yourself domain and range.